Good afternoon. Today I'd like to show you how to use the Extract3D plugin for QuickView, which will allow you to take GDS2 layer data and extrude it in the Z direction so that you have a simple 3D model. Well, the first thing to understand is you can't take an entire chip and do this because your 3D model would be impossible to load. You need to pick a very small region of the chip to extrude. So let's look around and look in this area here. I'm going to pick this little device and extrude that into 3D. So to do that, we're going to first open the plugin. We have two tabs, one called Selection and one called Stackup. Let's do the Stackup first because that's the more complicated one. The Stackup assumes that your GDS2 file follows some standard CMOS physical layers. The assumption is that the surface of the device is at 0, 0. Any layers that you define as diffusion start from the surface and work down. The poly layer starts at the surface and goes up. Contact is right above poly, and it either drops down to poly, or if there's no poly present, it drops down to the surface of the device. So your M1 actually will connect to contact, and that'll either connect to poly or to the surface of the device. Let's see if we can apply that to our example here. I have a GDS2 file with a number of different layers, and I have a couple diffusion layers, 1 and 2. If I want to start this process, I click here on diffusion, and now I'm going to select the GDS2 layer. And to do that, I use the pull down, and I'll select layer 1, and it picks up the name I've put here. If I don't put a name, then I just have to enter it here. And now I have to give a thickness from the surface to the bottom of this diffusion layer, 0.1, and the units are microns. If there was two diffusion layers, then I could pick layer 2 here and say it only goes down 0.8. So it doesn't go all the way to the bottom of this diffusion layer. Now I'm going to go to poly. Poly layer is on layer 4, so I'm going to select layer 4. I'm putting in 0.1. Now contact, layer 7 is my contact. Let's put in layer 7 there. The next layer up is going to be my M1, so that's layer 8. And then on top of that, I've got a layer via on layer 9, and that's of class via. And then above that, I have another metal layer on layer 10, and that's also metal. So I've defined a Stackup, and I've put in some arbitrary thicknesses. This is what the program will use to do the extrusion. Now we're going to go to Selection, and we have several ways we can select the window that we want to process. We can click on Select Window, and then we can use a rubber band to select it. We can have the current window, which would be from here all the way out to here. We can specify the lower left and upper right corners of a window by entering the values, or we could specify the center, width, and height. So whatever is easiest for the user in terms of how you have your data. So I'm going to say Select Window, and now I'm prompted to click from here out to there. All right, so that's the window I want. I can give the name of my output file. So let's just call that Demo 8 and then W1 for Window 1. And this is going to be in the format 3DI, which is Artwork's own 3D format. I have this choice to clip output. And what does that mean? Well, you see if there's data here that goes outside the window, I can grab the entire piece of data, which could extend very, very far. Or I can have this data that crosses the window clipped or sliced right at the window. By clicking View 3D File when extraction is complete, it'll bring up my 3D viewer and I'll be able to look at my file. If I'm happy with all that, I can just click Apply. It makes the extraction. It should bring up the 3D viewer. So here's our 3D viewer. If I rotate it, you can see it's actually 3D. The Z distances are very small, so it's hard to see what's going on. We have a nice feature which is Z scaling. If I scale up the Z values, I can actually see what's going on between layers. Here I have my M1 layer, and there's the via between M1 and M2, and this blue is M2. The poly is this layer, and then I have some contacts that either go from M1 to the diffusion level or they go to the poly. Let's turn off some layers to have a look. I'm going to turn off the M2 first, and I'm going to turn off the via layers. There's only 2 of them there. And I'm going to turn off M1. You can see the contact layers that go from M1 to the surface of the device, and you can see in there a contact that goes from M1 to the top of the poly. So that's our 3D model, and then in the next video we'll show you how to convert these 3D models into something you can load into a simulation software or into a 3D mechanical CAD program.